Thanks, Robert, and welcome everyone to this very special evening, an evening that was 3 years in the making, if you can believe it. COVID kept postponing the event and postponing the event, and then speaker availability postponed the event, so we're very, very happy to be here and very happy that you are here with us tonight. So let me briefly say a few things about myself. My name is Ans Hekkenberg. As Robert mentioned, I am a science journalist. I write for a popular science magazine called New Scientist. And my background is in physics and astrophysics, which is why I'm very excited to be here tonight, because this exactly combines the two fields of our speakers here tonight. So, as a science writer, I noticed that I'm always asking the questions of what and how. What was discovered? What is the news of the story? And how was this done? How was this discovery made? What were the methods? Very rarely do we get to ask the how and the why questions. So tonight that is going to change, because we are very much going to talk about the big questions in life, the big questions about our existence and the universe. So for me this is pretty unique, and I'm very happy to share that with all of you tonight. So in order to dive into these questions, we have invited two theoretical physicists. They're in the front row right here. Our first guest tonight is Heino Falke. He is world famous for giving the world the very first picture of a black hole. This happened in April 2019, when the black hole of another galaxy was revealed in a photograph. And very recently, he treated us to a new photograph, namely the black hole in our own galaxy, the Milky Way. So this is done with like a telescope that is basically as big as the Earth, because it's all these telescopes that are interconnected. He will tell us all about it in a minute. Our other guest tonight is Renate Lol, and she is also doing something very, very cool. She is combining like the two grand theories of physics. So in physics we have basically, more or less, two big theories. We have the theory of general relativity, as laid down by Albert Einstein, which describes space-time in a geometrical sense. So it describes like the grand scale of the universe, the big things. And then if you look at the very fundamental level, like the level of the very tiny, our world is described by quantum physics. So the rules of quantum mechanics. These two theories are both super successful in their own, fields, the big and the small. But we don't know how to unite them. We don't know how they make sense together, how to make them interwoven. Renate is working on this. She is making a theory of quantum gravity that will unite these two huge things in physics. As you may notice, their common goal is basically uncovering truths, fundamental truths, about the universe, about the world around us. How does the universe work? Why are the laws of physics the way that they are? Is there a place where the laws of physics maybe break down? Can these laws of physics be united into like one fundamental truth? And these are the types of questions that they deal with on a daily basis. So they conduct research in a very in the same tradition, in the same way. However, when it comes to their beliefs about the world and maybe our purpose here on Earth, maybe, the power of science, like fundamental questions like that, their worldviews are different. So tonight we're going to delve into that. We're going to really talk about that. So let's talk about the meaning of the universe, small topic for the night. I'll briefly take you through the program of tonight, and then we'll get started on with our first speaker. So in a moment, I'll invite each speaker to tell you a little bit about their work. So they'll take the stage, and they'll talk to you for a little while to explain what they do in their work. But before we do that, well, let me get to the after first. Time doesn't need to be chronological all the time. So after they have given their presentation, I'll do a little interview session with them, where we'll just get into a little discussion, talking about some very big questions. You are welcome to join to ask questions at the time, but know that after the interview session, there will be plenty of room for discussion with all of you. We also want to know your views and your beliefs and the way your stance on the matter. So after the interview session between the three of us, you'll get involved and it will be like one big happy talk. So it's going to be amazing. So maybe we should get a little bit of a head start on that. And I would like to ask you one or two questions. You've all been given these green and red sheets of paper. I think it's pretty self-explanatory, but I'll explain it anyway. Green, if you hold up the green sheet of paper, that's a yes. If you hold up the red sheet of paper, that's a no. If you don't hold up either one, you either don't have an opinion or you don't know, which is fine. These are your options. So, to get a little sense of the room, I would like to know, first of all, we're going to be talking about science and faith. So on the matter of faith, who in this room is religious or has a certain faith? I see a whole bunch of green on that side. You kind of divided, you guys. There's a lot of green there, a little bit more red there, but I say it's 60% religious, 40% says no. Okay, that's good to know. And let me ask you this question. Do you feel that well, let me think of how to phrase this. Do you think that other people think, not yourself, but other people, like society, thinks that science and religion are at odds with each other, that they conflict with each other? Who thinks that people think this is the case? And no's are also an option, of course, right? I see a sea of green, a few no's. So for you personally, this is the last question I'll ask before we get to the presentations. There's a lot of people in this room who are religious, who have a certain belief. For you personally, do science and faith conflict for you? Do you feel that there's some struggle there, some problem there? Green or red? Green means yes, there is a struggle, and red means no, there is not. This is really interesting, because I see a lot more red now than I saw at the previous question. So society thinks, this is your guys' opinion, society thinks there is some sort of conflict there, but for you personally, not too much. We'll definitely get into that tonight. But before we do, I would like to invite our speakers to tell us a little bit about their work first. What do they do in their science? What would they like to achieve? So I'll get to the official part now. Here it is. First up is, of course, Heino Falke. He is a professor of astroparticle physics and radio astronomy at the Institute for Mathematics, Astrophysics and Particle Physics at the Radboud University in Nijmegen. His research focuses on, you might guess this, black holes, and also the jets that sort of like blow out of the black holes. He recently published a book, which is absolutely a recommendation, Light in Darkness, about both his own personal journey in discovering how to make a photograph of a black hole, but also more or less humanity's journey to get to that point. In his private life, Heino is active as a preacher for the Protestant Church, ledepredikant for the people who speak Dutch in the room. And he will tell us a little bit about his work, so please give him a big applause, Heino Falke.
Thank you very much. I hope I find. Oh yeah, okay. So I'll take you to on a trip, very quick trip to the end of space and time, and to maybe the big questions that we have. But maybe first, one statement on sort of my background as sort of a Christian, but as a scientist. Why I don't think this is actually a problem. It's actually a calling to be a Christian and to be a scientist. Many know this first verse from the Psalms: "The heavens declare the glory of God; the skies proclaim the work of His hands." I picture King David or whatever sitting in the desert, looking up at the universe and the night sky, and thinking about how wonderful this universe is, but also feeling that there are deep questions out there in the universe. And I think still today that you're drawn into the night sky and you feel there's something deeper waiting there. And for him, this was sort of something that reflected the glory of God, the glory of the Creator. And so I think for a believer doing science, it's just learning more about that creation, and maybe also learning a little bit about who or what is behind that world. Now, if we talk about general relativity, and Renate knows much more about this actually than I do. She's a really hardcore theorist. But there was a surprising finding that general relativity describes our universe, and it has sort of a weird property that it seems to produce singularities. And that sort of beginning and end of our universe, so to speak, or sort of time to some degree are, in between two singularities. This is a graph from Penrose which shows sort of space and time in one direction. And, everything started from a Big Bang, one point in space and time, and it was expanding. And that was the beginning of space and time. And then you have black holes where actually, part of the universe collapses into one point. It's not the entire universe, so it's not, the analogy is not perfect, but one part of the universe is collapsing onto itself and forming another singularity, which is actually intraversible. And that's also where time seems to stop, at least seen from the outside, as if time stops. It was interesting that Einstein developed the theory, and it was Lemaitre, actually a Belgian priest, who developed that theory of the expanding universe against actually the intuition of Albert Einstein himself. And and general relativity was predicting that something like black holes could form. So if you have a lot of matter, too much matter, for example, the center of a star explodes, then the central part is collapsing. At some point, gravity will take over. It will become stronger than any other force in the universe. And matter just keeps collapsing into an infinitely small point. And then what happens, you form what's called an event horizon around it. And that's the virtual membrane, where a point where the gravitational attraction is so strong that nothing that crosses that membrane ever can escape, not even light. And if you have that case, because light is the carrier of all information, it's the fastest agent we have in the universe, worse, that if not even light can escape, nothing can escape. No information can escape from such an object once it goes inside. There's only one way towards the singularity. And that was a very theoretical idea. Einstein didn't like it. He didn't believe. Einstein didn't believe in the Big Bang. Einstein didn't believe in black holes. So whenever journalists write, we've proven Einstein right, we've proven his theory right, we've actually keep proving Einstein wrong all the time because he didn't believe in many of the things in the end that came out of his theory. And so at some point, people were wondering, do they exist? And there's a lot of evidence that black holes exist in the universe in the 90s, in the 2000s when I was doing my PhD. But we'd never seen one. And at some point, we had the idea that in the center of the galaxy, there is a supermassive black hole, we thought. We had good evidence what the mass is. And I was working on trying to understand the radio emission from this. How is the radio emission produced? Where is it coming from? And I realized that the radio emission is actually coming from a region directly surrounding the event horizon. If there is a black hole, this black hole light would be shining on that black hole from all directions, and light would disappear in this shadow, in this event horizon. And that would actually create a dark region called what we call then the shadow of a black hole. And light would be captured. And so we calculated this in 2000, and this is sort of the size of the black hole, but the light actually will be caught much further out because light is bent. And so if you have a glowing gas cloud, for example, think of a candle, candle light, and then you put a dark object in the center. Well, it's a wick in the candle. You see still the wick through that glowing light. If you put a black hole there rather than the wick, that's what you would see. Actually, the hole that you would see would be bigger than the black hole because of the light bending around the black hole, and you would get this shadow, which would have a very characteristic size. And so that's the picture that we predicted in 2000. We gave it a nice color. It was radio emission, but sort of we made it glowing red just to make it look nice. And then, this is actually another galaxy. There was 20-year work trying to get to the experiment to do this. And as you said before, we did this experiment with radio telescopes combined over the entire world, trying to look into the center of our galaxy. Well, this is our neighbor galaxy, but I just use it as an example. And this is then the result that you've seen. Now, it used to have sound, but the sound is gone anyway. Now we're zooming into the center of the Milky Way, into the radio emission, deeper and deeper. These are several hundred light years, the several few light years that we're seeing. This is a streamer of gas going around the central radio source, Sagittarius A star, as it's called. That's the point that was always suspected to harbor that black hole. And then when you get close enough with our big worldwide telescope at the highest frequencies, that's what we saw. It's at the edge of the resolution. It's clumpy, it's not as nice and smooth, but what you see is, you see the darkness and you see that ring of light surrounding it. And so, and it was exactly the right size and shape as predicted. And so you're literally looking into the darkness of the event horizon when you see that darkness. And that's an amazing moment to finally see what was a dream for over 100 years sort of in reality. Seeing is believing, as we say in science. And I think in the book at some point I wrote, but also, if you do such an experiment, you also need to believe that you will see at some point in science. Yeah, it's not that you suddenly see and then you believe. You first have to have an idea what you will do, and you have to believe that the ideas might work. So that's that I think is sort of a change, really. Putting supermassive black holes, they're physical reality now. They're part of our science these days. They are everywhere. This is a galaxy at 2 billion light years away that you see here. And if you look in the optical, and see actually all kinds of other galaxies surrounding it. And if you look at what the radio emission shows, then you see that there's a beam of radio-emitting plasma coming out of the very center. In fact, that beam is produced in the vicinity of a supermassive black hole. And that's something you see throughout the entire universe. They are everywhere, these black holes. So the universe is littered with supermassive black holes. And galaxies. And so you see all these galaxies in the background. And there's this other observation that we now know for many, many decades, that actually all these galaxies flow away from us. They escape from us. And the general explanation indeed is that this is the signature of the Big Bang, that the universe was created at some point and was expanding ever since, and everything is going away from each other more and more. And that was, as I said, first described by Lemaitre. And I think last year there was an exhibition in Leuven where I found this graph, which really, I stood in front of it in awe. As a physicist, it doesn't make you tremble, but it made me tremble a little bit, like like for Catholics standing in front of a Catholic reliquia. I don't know what that is. So holy peace from science, because that was the first time someone had drawn the history of the universe on one single piece of paper, with a pen. What you see here is sort of the time again, and then the size of the universe, and you see it sort of expand, and then it could collapse. That's the possibility. Or it would sort of, stay on a level and just stay as it is. Or it would actually escape and just accelerate and further, go apart. And that's exactly what you find in all textbooks today. And in 1929, when he was drawing this, he was the only person on this planet who had any idea, how the universe could look like. And that's amazing. And there was another thing. You can't read it, but so on the left it says t equals 0. Yeah, that's sort of the universe had a beginning. And for him, this was also a very important realization. That sort of there is sort of an end where sort of our physics equations break down. Well, it doesn't see that physics break down, but there is sort of a beginning of this universe, and sort of and the origin, remains in a cloud of mystery behind this. And we have many ideas these days, what could be even before, but are they testable science? That's a big question. And even if you have some science that goes before the Big Bang, where does that come from? And so every creation story of science today, never starts from scratch. It always starts with at least some pre-existing conditions and with some laws of nature that turn that something, or even that nothing into something. Yeah, you never start really from scratch and from just first principles. And so, this is our modern scientific creation story. It starts with this, beyond, out of this singularity, into the Big Bang. Space expands. You have this hot Big Bang. In fact, the beginning, everything was light-like. Matter didn't really exist, and it froze out of this expanding universe. I always thought that the first words were just, amazingly powerful of Genesis. The first three words are just in the beginning. There's a beginning. That's already fundamental. And then there was light. Okay, but then there was something else that struck me when I wrote the book, and it said, "And God said." So even before the light, there was a word. In the beginning was the word. So again, in every scientific story, you always start with the laws of nature. So to speak, the word, that describes it. Where does that come from? What does it reflect? And to me, as a believer, also laws of science are sort of words of God. It comes from a first principle, a first cause, which we call God. That's a philosophical God. There's also spiritual God, but let's talk about this later in the. Yeah, I think that's what I wanted to say. And okay, yeah, that's some advertisement. If there's a language you
commercial
you
break.
wanna...
No, that's perfect. Thank you so much. So before I let you go, just one question for you before we switch over to Renate's story. So you've achieved the photograph that was 20 years in the making, that you decided, we should be able to do this. Then you took the photograph. It's here now. Now what? What are you going to do next?
Now you see, now you want to understand. It lets us understand how black holes really work. There are lots of effects which we can see for the first time, perhaps now. And I'd love to do what Renate does. At some point, think about the really fundamental questions of gravity and space-time. And as I said, I'm not smart enough, but at least now I can ask questions, and people listen to my questions, and that's a good thing. And they talk to me, and so I had to do all this work, and suddenly people talk to me. we can discuss all these fundamental questions.
Well, you've made it.
That's what I really enjoy. So.
Thank you so much. I would like to invite you to take a seat so Renate can take over. Give him a big applause, of course. Yes. Thank you, guys. So next up is no surprise by now. It's Renate Lol. She is a professor of theoretical physics. So as Heino said, the smartest of the smartest. At the very same institute that Heino works at, namely the Institute for Mathematics, Astrophysics and Particle Physics of the Radboud University in Nijmegen. And as I mentioned, her work revolves around finding a theory that unites the scale of the teeny tiny quantum thingies with the huge big scales of the universe, where general relativity reigns supreme. Renate, the floor is yours. Give her a big applause.
Now, I feel there's a lot of pressure on me. I'm the smartest of the smart, and then I was called a hard theorist. I'm not sure I should take that as a compliment. But nevertheless, yes, I'm a theoretical physicist. What does that mean? I look for laws of nature, and I look for new laws of nature. So, of course, in physics, when we think physics, people think of stuff, right? Stuff, is made from atoms, molecules, and there are clever physicists who, put together these atoms and molecules in new ways to make new materials. So that's, one outcome of what, physics does for you. But I'm working in a somewhat more immaterial branch of physics, and that has to do not with the stuff, but with the entity, that houses or provides a background to everything that is, namely space and time, or, in a unified way, we've been thinking for more than 100 years, space-time. So, if you like, I'm talking about the container which contains all these gadgets and other things, and all these atoms and molecules. So you might say, okay, space-time. So I'm claiming even empty space-time is something interesting to study. So how come? Well, already Einstein told us it is so. So imagine I just take here a little bit, a piece of space. Of course, it's not exactly empty because it's full of, air molecules. So let me pump out all these air molecules, and I'm telling you, there's something interesting, potentially interesting, to be said about such an empty piece of space-time. And it really has all to do with Einstein, who, was already quoted and will be quoted more often, I feel, tonight, who described gravity, translated what we are thinking of gravitational forces, right, the apple falling down, as really a structure of empty space-time. So think of the very, typical situation out there in our universe first approximation is just very, very empty. So there's not a lot of stuff, but imagine a situation to have a heavy star somewhere, like our sun. So, and I have a planet that circles around it. So already, Newton formulated, end of the 18th century, universal laws of gravitation. So, and he would say, okay, there are two masses, they exert a gravitational attraction on each other. And that is, well, how is that transmitted? Well, in some miraculous way, through empty space, and that's what we call gravity. And that keeps the planet, right? The planet doesn't escape, but, turns around this heavy star. Now, what Einstein said is there is a different way we should look at this. We should think of this heavy star as producing a structure in empty space that surrounds the star, and that structure we call curvature. So that's the way, so the space itself is not straight, but it's kind of bent, depending on what mass and energy is there. And why is that a good picture? Because it seems to affect, so there's nothing that escapes gravity. So there are no gravity shields. So the heavy star imparts on the surrounding space-time a certain structure that is felt by anything. So it's not just felt by the planet, who kind of feels the attractive force. It's also felt by the light ray that passes close to the star, because it will not travel on a straight trajectory, but it will be bent towards the sun or the star. So that's the bending of empty space and time. And of course, the gravitational waves that were discovered a few years ago are also a structure of, it's mind-boggling, of, just ripples in empty space-time. You will say, oh, well, what ripples? Well, it's just a property of empty space and time. What I want to say, what I want to emphasize here, is even in this classical theory, right, which is more than 100 years old, there are things that are very counterintuitive, and you think, what on earth is going on there? So what is there? There's nothing to be seen. Well, but there is something there. And of course, physics describes exactly how to measure that something. And there are the physical attributes of that space-time, and I can go out and try and measure them. Okay, so what am I interested in? I'm interested in, as Ans already said, I'm interested in what happens to gravity, gravitational forces, and therefore the structure of space-time when we go to tiny, tiny, tiny distances. So why is that interesting? Well, it's interesting because, you see, the matter, the stuff that sits in space-time, as I said, imparts curvature. But then we know from everything we know about how matter behaves and how atoms, molecules, etc. interact, the fundamental interactions, their dynamics is governed by quantum laws. So what is quantum? How are quantum laws different from classical? Well, I can only wave my hands. It's just the idea that it's wrong to think of an object to be in an exact place, at an exact time, but you should think of it as more like a probability cloud of where the object is. So that's captured, of course, mathematically by a certain structure these quantum theories have that talks about wave functions, and I said probability amplitudes, etc., and things that can happen that the cat is alive and dead at the same time, the Schrödinger story, or that there are certain uncertainty relations. So it's captured by how we think about matter. Now, since matter curves space-time and matter is a quantum thing, we also believe that really, if we ask for the ultimate understanding of space and time, there must also be quantum laws. And these are the laws we are looking for, and that exactly implies this unification of concepts from two very different parts of physics. Gravity, stuff sits there, exerts gravitational attraction, bends space-time, and pertains to mostly large scales. So the dynamics, as you have already seen in some of the slides that Heino put up, the behavior of our universe at large, that it expands or it recollapses, it's really governed by the laws of gravity at the larger scales. So what becomes of those when we go to these tiny, tiny, tiny scales? Why is that a difficult question that people have thought about for more than 50 years and haven't come to one conclusion? Well, one difficulty is that we cannot really perform experiments at the scales where we believe these quantum effects are important. So that really hampers us. But we still believe it's very interesting because we believe, for instance, when we go back, in time, in the history of our own universe, towards the Big Bang, at some stage, the scales are so extreme, the energy is so large that quantum physics must be governing what happens, but we don't know the laws, and we are looking for them. It's big questions that are asked by the theory we are looking for, which is quantum gravity. So uniting the principles of quantum theory with those of gravity and general relativity of Einstein's theory. So what are my particular contributions, dumped down in 1 minute to the subject? So there is a difficulty, of course, if you go to tiny, tiny, tiny scales, you don't really know which concepts that are familiar and you think about, as understood on large scales, still are valid on these small scales. And it's also difficult to, since there are no experiments, how do we check that a given theory or idea is correct? So what I and colleagues, of course, have been doing is use as a substitute for direct experiments. So these accelerator experiments we cannot really perform at the so-called Planck scale, which is this tiny, tiny, tiny scale. We are using computer simulations to understand the predictions of our own theories. So you might say, well, but that's not the real thing. Well, that's true, but it's the closest we can come to testing the theories. So, and what do we expect of those theories? Well, one very, easy thing one should be testing is when I zoom out from these tiny, tiny, tiny scales, I go to the large scales. Well, at some stage, Einstein's theory should be a very good approximation. But people had been struggling to do even that computation. So people play around with little models that should work at the Planck scale. It seems like as a free lunch at the Planck scale, anything goes. You could. That's still the wrong picture. So imagine people talk about quantum foam. Space-time degenerates into little bits and pieces. But then, one thing is, how do you compute that such a foam gives rise to what we know is correct on large scales? So that turns out to be a very, very stringent condition, but the computation cannot be done. Okay, so I'm in an approach where not only can a computation of that kind be done, but also we've been able to find some connection between microscopic laws, So how do I have to choose the dynamical laws at the Planck scale to get out something that's reasonable and looks like a space-time we would find in Einstein's theory on large scales? So that's a contribution that I've given. And of course, I could talk about this for hours, but let's leave it at that and just give you an impression of what is now space-time at the smallest scale. Well, it's something like in a dumbed-down two-dimensional version you see here. So forget, the background is just artistic impression. What you see is a two-dimensional quantum universe that comes out of modeling, and you see it's a very spiky thing. So that's what we believe happens to four-dimensional space-time when we go to tiny, tiny distances. It has nothing to do with smooth and nice structures, but it's very quantum. It's the quantum fluctuations of space-time look like this, but of course it comes from a model, and then you have to still show, can you predict interesting from it? So why is it interesting for tonight's topic? Well, it really is at the boundary, of what we are doing there, of where theory might possibly, get us to. So it's a priori not clear how far the tools of mathematics, of theoretical physics, are still adequate and applicable in such a realm. So there are many questions you can ask there of, what is the right thing to do, and what perspective does it give us? Can we make laws, that are valid? How do we test them? How do we test their predictions? And obviously, to finish, there are of course questions also here where presumably there is no answer that physics can give. And that already connects to what Heino said. Who made the laws? Even if you find the laws, who made the laws, or where do they come from? Who said, even if we have the laws, how are the initial conditions chosen? Because the laws are not enough. You have to say, what happened at a moment zero, and from then, where from there everything developed. So these are all very deep questions, and I'm sure we'll come by those during the course of the evening.
Absolutely getting into those. Thank you so much, Renate. Give a big applause. Thank you so much. So absolutely, as you say, the universe is something we know more and more about and try to learn more and more about, but we don't know by means everything. And that is especially true about the things beyond the scopes of our scientific instruments. So we're going to dig into that. I would like to invite the both of you to take a seat. I'm just going to see what slide I'm going to land on.
You can choose.
This is the right one. That's good.
All right, so okay. The picture.
Oh, would you prefer your picture to be up?
No. I prefer to be in live rather than this picture.
You were on the left.
You're just going to have to look at the actual live thing. So, as I said before, guys, if you have questions for our speakers, feel free to raise your hand. I also have plenty of questions for them, and I'll get to your own views in a little while. But for now, I am very curious, of course, who we are dealing with here. So I would like to ask the both of you, actually 2 questions, so I'm just going to dump them all on you right now. So I'm wondering if you both can answer what science is to you, but also what religion and faith is to you. And I would like to invite Renate to go first.
Okay. Well, science for me is both my profession and, I would say, a way of thinking about, everything in life, including physics. So science is, well, there's a scientific method, but there's also something, analytical thinking and, not trying to pierce through bullshit, everything that comes with I would say with a scientific mindset. And of course, you apply it, of course, not in a very strict sense, in your daily activities, but I think it forms you in a certain sense. So it's a way of thinking about the world and trying to be objective, trying to, pinpoint your own biases and this kind of thing. So that's really the scientific method. To what extent it's really applicable in normal life. As far as religion is concerned, or faith, you said, well, I would call myself an atheist if asked, but I very rarely get asked the question. And so in a sense, the way I finished my presentation, there, of course, as I said, there are open questions, and you could phrase the question by saying, well, who put the laws there, right? Or who, chose the initial conditions? I don't think it's a particularly, helpful way necessarily of thinking about it. So I don't feel I have to invoke, say, a grand creator or, appeal, to some outer entity, like being religious or so, to address a question or even to leave holes in our understanding.
Do you feel that science will be able to answer these questions of how did the Big Bang start, for instance? As Heino said, there might be something that started it. Do you feel that science will have the answer to those questions eventually?
I don't think we will. We will be able to look further back in time. Now we extrapolate Einstein's law back in time, but then I said, we come to a point when they're clearly not valid, so you cannot apply them. So what I'm concerned about is then a few microseconds before where quantum laws will apply. But presumably we will not be able to understand, so what was the initial condition if there was a beginning?
Yeah.
And that may be just outside science. And then you can ask, well, perhaps it's not a good question to ask. It's of course also true. There are, questions that seem maybe perfectly sensible, but well, they are not because maybe they're outside. It's just our extrapolating and us using words in a certain way. So maybe the question doesn't make sense.
Okay, thank you. Heino, I expect that your view might differ on this. Can you?
I certainly have exactly the same view as Renata, certainly on science. I mean, science is it's a calling probably for both of us. It's a method that we use, but it's also a human enterprise, which we've learned and acquired, which we've given ourselves rules that we try to adhere to, and not everybody does all the time. That's why science sometimes can be wrong. But in the end, we found a way to sort of steer, usually towards the right answer. I think that's it's definitely not something that can answer all the questions. I suspect Renata will agree to that, and we shouldn't burden science with a why question, for example. That's not what science is about. It's not asking why questions. It doesn't give you purpose. It's not about purpose. It just describes how things are. And that's where sometimes I have a problem. Science gets sort of too I'm very emotional about science, right? But at some points it becomes almost a religion, right? And so that's something we should avoid. And what's religion? I think it's also a human enterprise. It's the combination of experiences that humans have, of stories, of revelations, and it's actually tested in time as well, a little bit like science, because it has grown over time. And
in what sense do you mean that it has grown over time?
Well, if you look at the Bible itself, I mean, you see sort of an evolution of faith, of knowledge, how you speak about it, and more experiences are added, and we still do. I think we still get to know more, and adding science knowledge these days, gives us new views into even our faith, new pictures. If you read in the Bible, there's shepherds and sheep and whatever, and now we have molecules and atoms and whatever. They're not in the Bible, but they still give you, and light, what's light? They still give us new pictures. But it's a way, it's also a language that allows us to communicate about our inner feelings, about our deep questions, about the why questions, and what we've sort of experienced as humans. And we are also spiritual beings. We have spiritual experiences, feelings, questions, and religion allows us to talk about this and communicate. That's religion as a method, right? Faith is still slightly something different. Faith is something that you may decide, or you have, or you acquire. It's something deep in you, and that's something that religion helps you to share. So we have to separate a bit what religion is and what faith is.
Do you feel that the question I asked earlier, that science will be able to explain everything about the universe?
No, of course. And in fact, science, that's a nice thing. I mean, that was a revelation that Lemaitre had, and we had many other examples, that science actually also sees its own limitations. That's cool about science. I mean,
Like Renate said, like
Yeah,
before the
absolutely.
Big Bang, we
It's-
can't see that far.
I mean, about this picture that we had about the galactic center source, we had that already more or less in 2018. I mean, not this one. I mean, it got better and better with time, but basic things we had. And when we worked 2 years full time, most of the time we worked on trying to quantify the errors. The limitations of what we know. How much of that is real, and what can we believe and what can we not. So understanding your limitations is a fundamental part of science. Yeah, what was the question? But anyway.
Do you think science is able to explain everything about the
Yeah,
universe?
no, I think it cannot. And if you think about, at some point even, you cannot say where one particle is, right? So you can't even answer these questions exactly. And you cannot predict complicated systems. I gave one example in the book, which struck me, was the calculation of 3 black holes, not even in Einsteinian theory, just Newtonian, 3 black holes orbiting around each other over the lifetime of the universe. And you'd think with computers you can perfectly calculate them, but you can show that you can, with infinite precision, you can calculate forward and backward. You don't get the same answers because these systems are chaotic.
Yeah.
And so the smallest quantum changes, where the universe is no longer smooth, will actually make things on a large scale behave very differently. So we cannot predict the future. We cannot completely post-dig the past.
Yeah. So I'm going to stray a little bit away from the universe. Straying away from the universe sounds a little silly, but I'm curious, Renate, you are a very, let's say you apply the scientific mindset to every aspect of life. Do you feel that the human experience can be explained by science, like the way we are? Basically, what I'm asking is, are we, machines, not in the sense of, robots, but can the human experience be explained by basically how we are put together, how our molecules work, how our neurons fire signals? Can everything we experience be explained by science?
Yeah.
Do you think?
Yeah. So there's of course the distinction of whether in principle or in practice. So
Yeah,
what
absolutely.
Heino already mentioned. So if I have our human bodies are extremely complex systems, I would say, much more complex than whatever we find out there.
Well, that's a
in the
compliment for all
formation
of
of
us.
stars. Yeah, well, it's truly an unknown landscape. But you would also say, of course, we are learning more and more and more about also how you could say the mechanics and the chemistry of our bodies, which would have been, completely out of bounds, say 50 or 100 years ago. So that we can also, what fascinates me is, something like, mind-altering, doesn't have to be drugs, medication. Because feelings, we are thinking of our own feelings as being very authentic, that's just us. But we know also that certain drugs we use can just change us in a profound way, how we think of ourselves. So I would say there is still a lot to be discovered, right? And clearly also a history of things that have been discovered, even complex systems like this, and one should not a priori say this is clearly completely, beyond science.
Right.
Because, big discussions, where does consciousness come from? Can we explain it?
Right. Yeah.
Yeah. Is free will? Is it just an illusion? Does it matter? Is there a physiological parallel, or is there a physiological expression of that in some sense? So that are very interesting questions where science probably can contribute, I would say.
Okay. I know. How do you feel about this? Do you think that if you figure out the mechanics and the chemistry of it all, that we will be able to explain a human?
Yeah, and I think it's a very important question. Who are we actually? And I think in the Netherlands there was 20 years ago a big discussion about from ape to humans, right? So and there was a shock to Christians. And one thing that changed in my view of myself is that I now fully embrace that I'm physics. Yeah, I'm a collection of I'm dust. I'm cosmic dust. And in fact, all the dust that we're made of are made in stars. right? So was in stars came back here. By the way, it's also, you read back in Genesis, you're made out of dust and come back to dust, right? So that's very true. And everything that governs us is physics. There are laws, there are chemistry, and electrical signals, and that's what we are. In that sense, you could say we are machines in that thing. And you can use drugs to change it, you can replace parts. And yet, and that's a yet that I say, and that also, this biblical story of Genesis 3, where you have this sort of the ruach, the odem, the breath of God, right? That's in you, and somehow this complex machine of natural laws reflect something profoundly different from this table, which is made out of exactly the same stuff. Yeah, on a physical level, there's no difference between this thing and myself. Yeah, or the shoe and myself. What actually, is that shoe part of myself, or is it part of something else? I mean, it's part of me. It's sort of, we don't know. But if I believe that sort of the laws of God, the laws of nature also reflect sort of the Creator, then everything in me, which is made out of the same laws, reflects also the Creator. But that doesn't mean that everything in my life is predetermined, that nothing can change. Quite the opposite. I think that science tells us, in fact, there's a lot of freedom. Yes, if I jump from a tower, it's likely I'm going to fall, right? So this is
likely, yes.
Yes, but it could be that there is a big trampoline suddenly carried by someone or whatever. I mean, things can happen in life which are completely unpredictable, and also in your own life, and that's a mystery. That's a mystery of life. How that works, how that changes, why things happen the way they happen. I think that will remain a mystery forever, and I do believe still, on a fundamental level, that I can talk to whatever the origin of that universe, where this all came from, that when I sit down and pray, I'm not talking to empty space, I'm talking to the origin of all that, the Creator, and it has an effect somehow. I don't know how, but that to me remains a mystery, how that works.
Yeah. So I think we're getting to a very interesting point. Also something that both of you said in your starting presentations. I know you said seeing is believing when it came to the black hole. And Renate, you mentioned when it comes to space-time, there's nothing to see, but there's still something there. So I think this is a very interesting point. Is it rational, do you think, to believe in things that you cannot observe? And I would like to involve the audience in this one. So I'll repeat the question, and you can hold up your green sheet or your red sheet. Do you believe it's rational to believe in things beyond the observable? So things that we cannot experiment on. There are a lot of yes. Okay. I'll get into this with you guys in a minute, but I would like to know what you guys think first. So Renate, what would you say about this?
Of course, first one should define what one means by observe. So the way I talked about it is what we learn from science is that we ourselves, in our what I would call direct observation, using our 5 senses, we are very, very limited by being, creatures of about, this size, with really bad eyes, where we have
can't
eyes,
even see radio.
Everything's, sub-quality, but the package is still okay. But we are very, very limited. So we would have never discovered, if we just had these 5 senses, we would have never discovered, any of atomic physics, for example. Yeah? So clearly already there is a lot there, which is both not accessible directly to observation, but also, therefore, defies sometimes natural categories, right? So how do we think then about these microscopic things? Well, we make drawings, right? And in the beginning, people drew atoms as little balls, but then we made experiments and we said, oh, no, there's something very wrong about this picture of having little solid balls. In fact, there's a tiny, tiny nucleus, then there's lots of empty space, and then we have some electrons that fly around in some kind of probability clouds. So it's, I would say, well, science has already taught us not to rely too much on our senses and, mistake, just what we can see as real. Because also, for instance, quantum physics also tells us that reality, the concept of what is real and what that means, is in reality quite different from what we think it is.
So we're very limited observers.
We are very
in a
limited.
sense.
We are very limited.
Well, then maybe I should rephrase the question a little bit just to get to the sharp edge of the discussion. If you think about what we can observe, not necessarily human beings, but what our experiments can observe and what we can deduce
with our
from
extended
our
organs, you could say. Yes.
Yeah. So I'm curious, there were a lot of green. I'm going to involve you guys now. So we have a really fun microphone. I'm sure you've all met the microphone before, the Catchbox. I'll be throwing this at you. I recommend you catch, but if you don't, that's okay, it bounces. I was curious about the people who just said, yes, it is rational to believe in things that you cannot observe or experiment on. Can you please hold up your sheets again? I'm going to make it complicated for you because I'm going to ask you to hold something up and then throw something at you. Okay, good. Okay, I'm going to throw it in that direction, the guy in a green shirt. There we go. Oh, I'm not very good at this. But this was unfair. This is stairs that just bounced it back. So this is not on me, guys. That's better. So what is your view on this? What would you say? Why is it rational to believe in something if you can't see it or observe it? Is the microphone on? Can you say test, test?
Try.
There's nothing there yet. I'm looking at people who should know what's going on. Can you try again? Just try saying something again.
Hello?
There we go. Yes. Good.
Okay, so I don't think I'm the best one to explain this, but...
You're all the best ones to explain.
As said, we are very limited in what we can observe, and also even if we extend our senses, or how you call it. I think it's very rational to believe there's more than what we can observe. So for me, it's actually very simple.
Our experience and our methods are limited, basically.
Yeah.
So the guy in the red shirt next to you had a red sheet up. So I'm also very curious why you feel it's not rational.
So I said it was not rational because I feel like it doesn't necessarily make sense to worry about things you can't observe, because the universe around us and the people we know are all things we can observe, and that's why they matter. But to worry about things like what is before the Big Bang, it could help us in some way eventually, but there are much more pressing things to worry about or to enjoy or stuff like that. So that's why I think it's more rational or more relevant to believe in the things we see and feel every day.
Interesting. Can you throw the box back? So I'll try to catch it this time. There we go. Thank you. So this is an interesting point. So you say, why worry about these things that we can't see? So I would like to get back to you now with a question. Should science try to answer every question? Heino, how do you feel about that? Maybe I should phrase it the other way around. Are there questions that science should not touch?
No, I think science should even try to answer every question. We should just not expect it to be able to answer every question. But sometimes you can answer a question you thought was not answerable at all. And thinking a little bit beyond helps you to actually find new avenues and new directions. So in that sense, I think it does make sense to think about what's before the universe. And even if it's not observable eventually, it's still, you still have to make a choice in what you see there. And I think it does affect the way that we lead our lives today. And therefore, it does have, these abstract things have a value and have an impact, sometimes more than facts have. So it's important to clarify them, to say what the basis is on which we are grounded. And then we can talk, and then we can understand each other.
Right.
If I say there's no life whatsoever, there is no justice in life, and then no afterlife, and humans are just machines. without any spiritual, it's a very different view than to say, everybody is loved, has a purpose, which is, just something I say, I make up, but it's something I believe in, and it has to do with my belief in a creator. So
it's worthy of discussion.
We have to live with abstract concepts, and I think that's where our life is based on. And again, religion helps us, for example, to phrase them and to give them a place.
Right, that brings me to another question, and this is one of the big ones, I think. So it's going to be challenging, but your best instincts is what I'm asking for. Do you guys, sheets up, feel like the universe arose by chance? Are we here by chance? That's a nice mix. All right. I'm going to pick a victim. Up here in the red vest, I'm going to give this to you. You said no, if I got it right. Why? What is your view on this? Why do you think that?
I personally also believe in a creator, and I think I live here for...
I think you either need to hold the microphone a little closer or it has to be turned up. Try it.
Test?
Yeah, I think we hear you. You guys hear it too? Good, yeah.
So I also think that there's a creator, and so that I live here for a reason. So my life has a purpose, and like if everything happened just by chance, I don't think I would be here. So that's why I held up my sheet.
Okay, thank you. Who said we are definitely here by chance? Okay. The lady up front, I'm going to give it to you because you're too close to throw up.
Well, I don't believe in a creator because I think it's humanizing the questions of science. Like we are just a little piece of everything, and believing in a creator is like, well, as some kind of being who creates something like it was a human being, but I don't believe in that. And I believe there's a lot of things happen by chance, so also things in nature, and they just pop up.
So to believe that there is a purpose might be a little arrogant of us. I know. What do you think about that?
No,
well,
I spoke before. I think it's...
Yeah. Okay. So. Yeah, so the discussion, I would say the question is ill-posed. That's always the cop-out for scientists. And it reminds me, of course, there was a discussion also, red shirt. You made a good point. It made me think of a hot discussion that was led in theoretical high energy physics circles, and that is one of the existence of the multiverse, right? So the idea, that there are many branches. We are just sitting in one branch of the multiverse. So there are many incarnations of this multiverse. But one of them is, well, again, not with all, but with most, that it's something that is in principle unobservable. So, there are these other I postulate there are all these other branches of the universe, and maybe while we're sitting here, we branch off in one way, and the copy of us branches off in some other way,
See, guys, yeah.
Like who's read the anomaly. So this could happen, but we would never understand, because then, they are causally disconnected from us. We can never exchange signals. So then people say, well, look, this might be a nice model, but it's not physics. That's metaphysics, right? So, and you can have maybe an opinion, you can like it or not like it, but it does relate to your last question, because if you're saying, oh, well, are we here, by accident or by purpose? You could also say, so what was initially the space of all possibilities? Right? Is there such a thing? And again, that comes then back to the initial conditions of the universe, and I think we won't be able to say anything about those.
So you do feel that we're here by chance of the laws of the universe?
I would say, again, if we open our eyes and just look, again, as you said here in the front, we are just a little speck in a vast universe. And there's lots of stuff. There are probably, humanoids, who knows, other forms of life out there somewhere. I mean, it can't be otherwise, I would say. So what do we then say? I mean, we are who is there a creation? Is there a purpose? I think, it's largely random. I would say,
How do you feel about this? Do you think that we as humans might take on too big a role if we say there is a purpose to us in the universe? Are we maybe being a little bit, lopen we naast onze schoenen? I don't know the English version of this.
That definitely is chance. I think chance is part of science. And let me speak also theologically. I mean, at some point, we are sort of living not in paradise, right? So we are not sort of, God caters for everything we do, whatever. We are sort of cast out, and we have to live with the realities of life, and that include chance, right? I mean, just for the people who know the Bible, there's a story Jesus tells about the tower of, I forgot the name, which crashed and killed 20 people. And he was just saying, well, it just happened. It's not because they did something particularly bad. Chance is part of our life and creates a lot of good things, but a lot of bad things as well. A lot of evil comes just from chance. You're just at the wrong time, at the wrong place, and you're killed or whatever, or hurt. And so that's something we have to live with. And so, yes, I think chance is, we're also here by chance to some degree.
Yeah, not everything is predetermined.
That's true. But on the other hand, yes, I think we are reflecting, well, it's too complicated perhaps, but I wanted to say something else about sort of the creator. I mean, we also make this a human story. We don't have to, right? You can talk about the beginning, and people have done that also in theology. There's sort of this first origin. They just talk about the first origin, which whatever was there in the beginning wasn't sort of humanized, right? So you can do this. And physics wouldn't be able to tell. I think physics only can tell you there's something unexplained before the Big Bang. Is that, and you can call this God, a philosophical God, right? But that God doesn't need to be someone. Could be something. Yeah? And the way why we think, why we believe it's someone, it's because we are here. Somehow the laws of physics that reflect the origin, that come from the origin, are able to think, to talk, to sing, to tell stories, to ask deep questions. And suddenly matter, ordinary matter, together with the laws of physics, ask very deep and fundamental questions. So the universe, to some degree, we are the part of the universe that asks questions. We are also the part of the universe that can pray. And again, the biblical view is that we reflect the origin. Yeah? Scientifically, I think we can say that. We are science. Yeah? We reflect the origin. But spiritually, we say we also reflect the origin. So the origin is not just something, like we are not just something. We are someone. And so that first cause is also, in a bigger way, someone. I think that's the reasoning. It's not a proof. We cannot prove it. But I think it's reasonable to think. And it's then the matter of leading your life through the chances and the valleys and hills of this universe, your life, and also the universe, to realize that, spiritually you can actually expect something from that creator. And that's faith. That's pure faith, where you say, okay, I believe you are there, and I talk to you, and I expect something of you. And I think I have a place here. I have a role to play. For a short moment on this little piece of dust, but it's a very special role I can play. That's a role that this table cannot play. Each of one of you can play a very special role that nobody else in the universe can play.
I just want to encourage everybody to ask questions as well. There was one over here, so I'm going to give this microphone over.
Yes, I think humans are pattern recognizers. They are group beings, so having a purpose gives us a reason to be a big group and to be more successful, things like that. And we have these biases, and believing in free will, it is very nice to think of yourself as being able to choose. So I myself personally have a big problem to accept that all science points to the fact that we do not have any free will. I just do not want to believe it. And in the same way, the chance is very harsh. To live in a universe that does not have a purpose, but is just random, is not a nice thing to live in. It can be frightening. And so, do you think bias can affect humans in having faith, or I don't know how to ask the question. There can be, for instance, it could be an evolutionary voordeel, advantage to believe. So because it unites people and it gives a greater purpose, and so it doesn't keep you down and depressed, but you go and try something out, and one of the groups that tries something out can then succeed and go on live in their...
Maybe is religion...
It's long enough.
Is religion maybe determined by either we want to have a sense of purpose, it makes us feel good, or maybe that helped us survive, basically, to have this idea? I see Renate nodding, so I'm very curious.
No, exactly. No, these are very interesting points you're raising. So I think just to, if you say, oh, we are all random, I think that just sends the wrong message, right? As if, there were all these, molecules, flying around in the universe, and then they spontaneously assemble to someone like you and me. But of course, there is evolution, and I think evolution, has clearly a random element, right? That is part, but it's also something we don't fully understand. But I do believe it shapes. I mean, having been shaped by evolution and the survival of the fittest, clearly makes it seem very plausible that things like religion as a way to organize ourselves and having certain beliefs, indeed, probably convey an evolutionary advantage. Yeah. So, and in our, it's also this, we are forever searching, right? I mean, humans look for answers, and it's very comforting if something does provide answers, and if you are part of a collective that has agreed on certain rules and also on certain, ways to think about what it means to be human. I think that can be very comforting and, life extending and healthy in general. Without, I don't think this is something trivial at all.
No, I think it's very good. I wanted to try to answer. There's 10 thoughts in my head which are going in all directions right now. So first, of course, I mean, the fact that something works and works well, I think is not an argument that it's wrong. So, and it's interesting to see that, and I fully agree, we are science, we are evolution, we've emerged out of science, and somehow that evolution has given us a sense of purpose and spirituality. So science actually gives us that. So in that sense, it's scientific reality. And science, the same science, has given us mathematics. Mathematics, it's equally completely abstract. Yeah, it's something that only we know. Again, this table doesn't know about mathematics. It follows some rules that you can approximate by mathematics. And if you go to really the details, quantum physics, it becomes very difficult to write down simple equations and solve them. And so that why is mathematics then true while faith is not? Both, one is more complicated to test, obviously. Yeah, mathematics works in very simple circumstances, but when you describe a completely complex world, it too, is not sufficient to describe everything. Faith, tries to, is sort of maybe the highest level of trying to, in a very abstract way, trying to describe the world. So I think it has a good chance that it's actually correct, and it works for me. So to me, it's good enough. Like math works. So.
Well, this might get to an interesting point. in science, we often have to make assumptions to be able to, move on and create our models. Religion also has to make assumptions, I would say. Are these two types of assumptions fundamentally different, or is it the same thing?
Well, I think one has to reflect, or also when one does science, one has to reflect on the relation between, theory and kind of reality and nature. And I wouldn't subscribe, for instance, to mathematics kind of existing or being true in a really abstract sense. But I think it's also a human endeavor. And of course, we also lay down certain axioms, and then internally we prove certain things. Well, that's math. But then you have physics. We have laws of nature. But we know also these laws, they are built on Gedanken situations which are idealized and which are not purely realized in nature. Nevertheless, but they're quantitative, so that's a great thing. And you can also say something about to what idea the true physical situation you're trying to describe deviates from the idealization. But nevertheless, one shouldn't mix the theory with the reality. This is famous Einstein quote saying, well, what's so amazing about nature is that there seem to be these laws.
And we can understand it.
And that we can understand them. And I think that is just, that hits the point, because the laws are, well, this is kind of our human, way of kind of constructing or putting a logic in things according to certain rules. And also we apply, scientific methods. That means evidence is there, but of course everything has error bars. So it's it's not a super tight, it's not a super clean story, but nevertheless, marvelously, it has got us very far.
So I'm curious for you, Heino, do you feel the assumptions, if I may call them assumptions, that you make for in faith are different from the assumptions that you make as a scientist?
Well, the interesting thing, the assumptions that we're talking about, also in science, usually come in hindsight. It's not that you start, I make an assumption and then develop a theory. You observe the real world and you try to distill the natural laws. And before that, you realize, okay, I have to make this and this assumption. Then I can derive those laws. This is something that comes in hindsight. And I think that's the same in religion, that you try to sort of, okay, observe this. We do this. We have this tradition. We have this experience, that spiritual experience. And we try to put this into a view. And we call that, that's theology. That's what theology does. And from that, we distill some spiritual laws. And when the Christian worldview, what is this? I mean, there is a creator which is distinct from the creation, for example, right? That's a very fundamental choice. That wasn't always the case, right? So you had many religions where sort of you had ghosts and spirits, whatever, determining the entire, everything, the stars and whatnot. And the Christian worldview was, no, these are things. The stars are things, little lights. And you can investigate them. They don't have a spiritual meaning. And so that is one of the assumptions, but which was distilled out of observations and experience. And then there are sort of ethical laws. Yeah, I think the highest one is, as Jesus said, love yourself and your next, love your neighbor and God like yourself, whatever. I can't say that in English. Liebe deinen Nächsten wie dich selbst. So it's this law of love, which was, of course, violated by churches throughout their entire history massively, right? So, I mean, every theology should start with what is the main law that Jesus gave. And that's how the ethics should derive. But it works the other way around. They start with all kinds of rules and little things and forget the big picture. So that's why I sometimes would like to see the scientific method more applied to theology, to point out some of these illogic, irrational, or inconsistent parts of theology or practical theology. Yeah.
So one thing I'm also super curious about, there's a lot of people here in the room who are religious, there's a lot of people here who are studying the sciences, obviously. Do you guys feel that, so green and red sheet again, do you guys feel that religion and science can enrich each other? So this is tricky, there's a lot of green, okay. I'm gonna try and throw this hard. I see like a pool of green over there, so it's literally anyone who catches can answer. So why do you, not why, but how do you feel that science and religion can enrich each other or help each other?
So science is based on observations and it's trying to derive those rules. At some point there's just a limit. It was before the Big Bang. There's no real science that gives an answer to that question. That's the point where religion basically comes in my view. So they're basically an extension of each other. They play by very different rules, but it's on the same continuous path towards, that tries to seek knowledge, tries to understand why things happen. And there are certain things like why does the cable not float around? That's clearly physics. And why do humans feel love? Is clearly not, in my opinion. But they both are on the same spectrum of just things we try to understand.
Right, so they have like a different realm to answer questions for you. Who just had a red sheet up? Can we put them back up? So there's one on your left, my right. Can you throw it over?
Sorry.
Oh, that's good. Yeah, perfect. Oh, that was a direct hit.
Nice shot. I wasn't ready.
We were having a friendly discussion, people.
Well, different opinion. That makes sense. No, the problem that I see that sometimes the risk can, let's say, outweigh the benefit of the contamination between the two. Because if you think, for instance, if you try to apply certain scientific view to more the religion/ethic world, you can arrive at something that is really wrong for the, let's say, humankind in a certain sense. When you're trying, let's say, to make decisions on ethics based on just scientific stuff. So think what's the evolution and this type of things. I mean, that's a risky area where you go. And the other side, if you try to, I don't know, in science, try to acquire this sense of belief or necessity of believing in something of faith, that could be risky because you try to, let's say, rock yourself in certain theories that you want to be true. That's something that shouldn't belong to science itself.
Yeah. So your point is they shouldn't mix, basically.
That we should be pay attention.
Careful.
Very careful. I see that the risk might be higher than the benefit, and I'm trying to mix those.
So I'm curious for the people in the room who are religious. Do you feel, okay, this is going to be a tricky question and a personal one. Do you feel that when you are conducting science, that you're basically like wearing a different hat, using a different pair of glasses, whatever metaphor you prefer, than when you are practicing faith? Or, you know, the other option is that for you it's a naturally mixes and it's fine to have those two mix. So if you say, you know, I separate the two, you can hold up the green cards, and if you say, nope, it's just the one thing for me, you can hold up the red cards. That is pretty cool. I see a lot of red, but also some green in the audience. Renate, I'm going to ask you a tricky question as well. Do you feel that those two should be separated? Yeah, it's a tricky one.
It's a tricky one. I would say yes. I would say yes. I would say yes. Of course, it always, you know, goes back to, well, how does one define religion? So I find it a little bit problematic to say, well, religion kind of is the stuff that takes over where our current theories end. Because that means, of course, you know, as we know and understand more, there seems to be then less space for religion.
So science is making religion redundant, in a sense?
Well, it's encroaching then on certain things that maybe, we had no other ways of understanding but through, you know, belief systems. And of course, these get corrected as we do understand more.
Yeah.
So I feel also that, these two things should live they do live in separate realms, it seems to me. And obviously, again, to paraphrase, not Einstein this time, but, Woody Allen is, the human heart is a very elastic muscle. So we can live with all, with ourselves, with, having parallel belief systems and applying one, to in a more scientific way, and others, to let whatever, our emotions, our beliefs, our faith in, some existence beyond ourselves, this kind of thing. So these things can still clearly coexist, and that might be even, as you said before, an evolutionary advantage for us.
Yeah. So time's ticking, so I'm going to move over to Heino for the last question, and that is, the big one of tonight, I guess. Same question, basically. Do the two mix, and maybe does the big question of today was, can a scientist believe in God? Do the two mix for you?
Of course.
I think can a scientist believe in God is sort of a pointless question.
That question has been solved, and I'm not the only one.
QED.
So, in fact, most of the science that we use today was based on scientists who believed in God. And they wouldn't even understand some of the questions we're discussing today, because that would sound weird to them. But of course, science is, as I said, is a method. It's a focus. It's like, when you prepare a book, right? You write the content. That's what you care about. Mm-hmm. But at some point, it goes to a typesetter, for example, right? And he or she looks very carefully at all the letters, and doesn't care so much about the deeper meaning behind this.
So it is a bit like changing your pair of glasses.
It can be changing. It's a different kind of questions you ask, different glasses, different focus. Of course, both are necessary. You have to read very carefully. If you read sloppily, the letters in the book, if you don't know how to read, you will not understand the story. And science is a fundamental part of our lives, and Christians and believers should be doing the best science they can, and they should not be biased by their belief in what comes out. They should be open. They should ask all the questions. They shouldn't be afraid to ask all the questions, because they're part of this creation, and God doesn't tell you, don't ask that question. He gives you all the freedom to ask all the questions you want. Feel at home. I talked to a journalist today, and I was saying, to me, the universe is like, my parents' garden. I can roam through them. I can explain, and actually a garden where it's not said don't touch the flowers. I can actually look at the flowers. I can smell them. I can investigate
free to
them.
Explore and free to ask questions.
But I can still enjoy also as a human being. I can investigate the flower, the tulip, and rip everything apart and know everything about it. But I can just sit there and enjoy that it's there and give it to someone that I love. And that's a completely different question. Of course, there's also science involved, some hormones and whatever. But I think it's still more than that.
Still chemical machines. No, I think that's a beautiful note to end on. So ask all the questions, be open to asking all the questions, give each other flowers. I think that's a beautiful summary of the evening.
So you summarized it well.
Yeah, right? So I would like to thank you both very much. Please give them a big applause for Renate Lol and Heino Valken. I'm going to give the floor to Robert in a little second, but before I do, I know... sorry, Robert. No, he's a student of Veritas, so before I give the floor to him, I would very much like to thank Veritas for having us here tonight and for organizing this event, as well as, of course, Studium Generale of the Technische Universiteit Eindhoven. You guys made this happen, 3 years in the making, but well worth the wait, I think. So thank you so much for making this happen. And before we leave the floor, I would also very much like to thank you guys, obviously, for all your insights, for sharing your thoughts and ideas with us, and of course, the interesting presentations. And absolutely last but not least is, of course, you guys, the audience. I threw microphones at you and you gave answers, so that can be quite challenging. But I think you all gave a very valuable contribution. So thank you for sharing with us, and thanks for coming here tonight. I think that's all I want to say. I'm going to give the floor to Robert now for the closing remarks. Thank you, guys.
Yes, thank you once again. To end, we have a small survey that we would like you to fill in. Can we go to the next slide? Oh, over there. This one. There's a QR code. So I would like to give 1 minute to the room to fill this in.